to Bhubaneswar, IOC Bhubaneswar campus, and IEEE Bhubaneswar section. Today, we are gathered here at the Pathani Samanta Auditorium, Nizer, Bhubaneswar, to witness a series of enriching talks, culminating in an inspiring keynote address on the theme Indian Space Program Pride of the Nation by none other than Dr. V. Narayanan, Chairman ISRO and Secretary, Department of Space, Government of India, our esteemed chief guest and keynote speaker for this event. To begin the prestigious program, I request our distinguished dignitaries to kindly come up on the stage and occupy their seats of honor. May I please invite Professor Damodar Acharya, Chairman, INA Bhubaneswar, Professor Hirendranath Ghosh, Director, Nizer Bhubaneswar, Professor Subhranshu Ranjan Samantrai, Head of the School of Electrical and Computer Sciences, IIT Bhubaneswar, Professor Sunil Kumar Sarangi, former Director of NIT Rourkela, and, of course, Dr. V. Narayanan, Chairman, ISRO. We now commence the formal proceedings with the lighting of the lamp. May I kindly invite all the dignitaries on the dais and our esteemed chief guest, Dr. V. Narayanan, Chairman ISRO, to kindly proceed for the lighting of the lamp. May I also request volunteers to assist or our dignitaries on stage? Yeah. Now, I request our director, Professor Hirendranath Ghosh, to present the bouquet to our dignitaries. I request the organizing committee to kindly come forward with the flower. Thank you, Professor Ghosh. To formally commence the session, I now invite Professor Hirendranath Ghosh, Director NISA Bhubaneswar, to deliver the welcome speech and his address on National Technology Day 2025. Sir, the stage is yours.
Good afternoon, everybody. Extremely sorry for the delay, but I'm really very happy. Everybody was sitting there for last more than 1.5 hours. That suggests that, where we exist. Anyway, good afternoon again. Dr. V. Narayanan, Chairman ISRO and Secretary Department of Space, Professor Damodar Acharya, Chairman INE Bhubaneswar Chapter, Professor Sunil Sarangi, Professor Subhrangshu Samuntre. It's my honor and privilege to welcome you all to the National Institute of Science and Education and Research on the momentous occasion as we gather to celebrate National Technology Day 2025. This day holds profound significance of our nation as the commemorates the successful nuclear test conducted at Pokhran on May 11 and May 13, 1998, an operation that went down in the history as Operation Shakti. This test not only demonstrated India's capability as a nuclear power, but also marked a watershed moment in showcasing our indigenous scientific and technological prowess. At the forefront of this historic operation were two visionary leaders, Dr. APJ Abdul Kalam, the then scientific advisor to the Prime Minister and head the DRDO, and Dr. R. Chidambaram, Chairman of Atomic Energy Commission and Secretary Department of Atomic Energy. Their leadership and our scientist innovation stand as a testament to our nation that can achieve through dedication, collaboration, and self-reliance. National Technology Day is thus not just a celebration of a scientific milestone, it's a reaffirmation of our commitment to progress through science and innovation. It serves as a reminder of the power of indigenous technology and the role of science plays in shaping the destiny of a nation. It is also a day to inspire the younger generation, to encourage them to pursue careers in science and technology and contribute meaningful way to India's growth. This year, we observed National Technology Day 2025. The theme is Yantra, Yugantar for advancing new technology, research and acceleration. The word Yugantar symbolizes India's emergence as a global technology leader, while Yantra draws from our rich scientific tradition and reflects the drive for innovation and scalable, impactful solution. The historic relationship between the DAE and ISRO is a powerful example of institutional synergy in Indian science. From the early days when ISRO was a part of Department of Atomic Energy under the leadership of Dr. Vikram Sarabhai to the eventual formation of Department of Space in 1972, both the institutions worked in parallel, complementing each other's strength and keeping India at the global forefront of technological advancement. NISER, though a relatively new institution under Department of Atomic Energy, plays a crucial role in this ecosystem, nurturing bright young minds and pursuing boundaries of fundamental science and research. As we welcome the chairman of ISRO to our campus today, it is not only a matter of great pride, but also an opportunity to deepen collaboration between ISRO and DE through NISER's academic and research endeavors. We hope this visit marks beginning. Okay. We hope this visit marks the beginning of many joint ventures bringing together the rich legacy of ISRO and DE with the fresh energy and ideas of NISER faculty, researchers, and students. Let this be a day of reflection, inspiration, and renewed commitment to our nation's technological future. Once again, I warmly welcome our guests, students, staff, faculty members, whoever is present here. Let us celebrate this day with a pride, purpose, and passion to drive India forward. Thank you very much.
Thank you, Professor Ghosh. Now, I invite Professor Subhramsu Ranjan Samantrai, Head of School of Electrical and Computer Sciences, IIT Bhubaneswar, to speak on INA and INA Bhubaneswar chapter.
Very good afternoon to all of you. Sorry. So distinguished dignitaries and the dais and Dr. Dais. Before that, I am really excited to see all the footprint of today's function is very high. So before that, I'd like to thank Professor Ghosh for inviting even school children here. Thank you very much. So today's keynote speaker and chief guest, Dr. V. Narayan, one of the distinguished scientists of this country. Professor Damodar Acharya, the chair of INA Bhubaneswar chapter. Professor Suril Kumar Sarangi, the former director of NIT Rourkela. I see Professor A.K. Tripathi, the former Director General of CPRI Bangalore. Professor P.K. Misra, a long-standing experience and very eminent professor of this country. Professor Padi from Science Bangalore. Professor Sarma from SOA University. The faculty members of Niger, students starting from the undergrad to research scholars, and the school children who are really waiting to witness this function. So I am really thankful their patience because it is 1 hour delayed, but they are returned here to see this function. So I will throw some lights on the INA, the Indian National Academy of Engineering, the elite body of this country, elite and apex body, which is including all the eminent engineers, scientists and technologists covering almost all spectrums of engineering applications and technology development. So INA functions as an apex body and promotes the practice of engineering and technology and the related sciences for their application to solving problems of national importance. The Academy also provides a forum for futuristic planning for the country's development, requiring engineering and technological inputs, and brings together specialists from different fields that are necessary for the comprehensive solutions to the need of this country and humankind. The activities of INA includes various programs, including technology policy and recommendations for various engineering applications, which are really helping or reaching the human society in different forms. This includes many activities promoting research projects, pilot studies, engineering educations, fellowships, scholarship, awards, and many other forms of recognizing people and technology which are really emerging solutions of different problems around us. INA has a fellowship mandate which really recognizes people of different spectrums of engineering and sciences. Right now, INA has almost 1,000 fellows who are staying inside India and 100 fellows outside. So INA recognizes people from not only, they may not be from Indian origin, but they have some form of contribution to the growth of this country. And no time the fellowship number should go beyond 1,200. Right now, this is what is the statistics which is with us. INA also recognizes people at the age of 35 called young associates. So these young associates are the people we believe, INA believes they can take many things forward. So we recognize people as young associates. And recently, INA has started something called membership programs, which includes associate and senior membership. To create a platform for new knowledge dissemination and come closer to the people, INA started opening chapters. So INA has almost 10 chapters in this country, like Mumbai, like Bangalore, Pune, Kharagpur, Chennai, all are the places. So INA Bhubaneswar chapter started in 2021. under the able leadership of Professor Damodar Acharya, the ex-director of IIT Kharagpur, and right now the advisory chairman of the advisory board of ISRO University, and chairing the INA Bhubaneswar chapter. This chapter is highly engaged in new knowledge dissemination process, including different talks and other programs. So INA Bhubaneswar chapter is organizing programs along with IIT Bhubaneswar, ISRO University, IMMT Bhubaneswar, Niger Bhubaneswar, and IOC ICT campus Bhubaneswar, and IEEE Bhubaneswar section, one of the largest platform for dissemination. This chapter has already conducted more than 60 keynote speakers, drawing many eminent people from across the country in different domains of engineering. Also, this chapter has conducted one of the mega event, which is called INA Convention in 2023, which is one of the benchmarking program INA has seen till today. So during this 38 year of history of INA is trying to bring people of eminence to this platform and creating a platform for knowledge creation, knowledge dissemination, and knowledge translation. So we must thank INA for creating such a platform where we all are coming together, and that is the reason we are standing together. I thank again the audience being part of this program. It's a very large audience. We are really thankful to Niger for arranging such a big audience for this program and returning back. Thank you all for your presence over here to observe this National Technology Day 2025. Thank you very much for your presence. Have a wonderful day.
Thank you, Professor Samant Roy. I request Professor Damodar Acharya, Chairman, INA Bhubaneswar Chapter, to share his brief address on National Technology Day lectures at Bhubaneswar. Please, sir.
Jai Jagannath. Very good afternoon and welcome to all of you to this nice auditorium. I could never imagine that actually so many students from the schools and other places will come here and fill up this 900 capacity, beautiful auditorium, possibly one of the best in our locality. Our esteemed chief guest, Dr. V. Narayanan, Chairman of ISRO and Secretary, Department of Space. We are really very happy to have you here. We have with us Professor Sunil Kumar Chadangi, who was former director of NIT Rourkela, and my colleague in IIT Kharagpur to be here with us. We are very thankful to Professor H.N. Ghosh, director of this Niger, who has taken all the pain of organizing this National Technology Seminar here. Also, we have our youngest fellow here, Professor Subhanshu Ranjan Samantaray, one of the professors in IIT Bhubaneswar. In the audience, we have got our esteemed INA fellows and my teacher, Professor Sant Kumar Mishra. Then also we have Mr. Ashok Tripathi. We have very young and dynamic friend, Mr. Radhakant Padi, and some future fellows like Madam Renu Sharma present here, and the distinguished invitees, guests, and my young friends. So far as National Technology Day is concerned, and its series of lectures are concerned, as you know, INA headquarters directed us, that is the INA Bhubaneswar chapter, to organize this one in a very befitting way. And with all the cooperation of our say, partner institutes like SOA University, IIT Bhubaneswar, IMMT Bhubaneswar, and IISER Bhubaneswar. Then we have also IOC, ICT campus, Bhubaneswar campus here, and very energetic IEEE Bhubaneswar section. We have been able to organize this 4 lecture series, and the first one, and befitting to the occasion of National Technology Day. As we know, the National Technology Day was celebrated. It came up from the Pokhran blast, and it was actually glorifying our strength in the nuclear technology. So therefore, our first lecture started with a topic on nuclear technology. So the lecture was actually given by Dr. A.K. Tyagi. Just a minute. Professor A.K. Tyagi, he is actually the head of Homi Bhabha National Institute in Bombay, and his lecture was on the sustainable development of nuclear science and technology, befitting to the occasion. The next lecture was again befitting to the, National Technology Day, was actually given by Padma Shri Dr. Kota Harinarayan, who happens to be the chief designer and even who has conceived the idea of actually light combat aircraft, and he has made it operational. He was also the vice chancellor of, University of Hyderabad, and his topic was application of AI in aircraft design. So he is a very young INA fellow of 82 years old, but very, very sharp in his thinking and also in his mind. And the third lecture is being given by Dr. V. Narayanan, whom all of you know now. So he also happens to be a student of Professor Sunil Sarangi and a product of IIT Kharagpur. So his talk is going to be Indian Space Program, Pride of the Nation. And the final one will be given by Dr. Binoy Kumar Das, who is also the DG of DRDO. Now, you have all seen the role of all this organization, whether it is, our BARC, or it is actually this, let us say, DRDO, or it is our aircraft industries, and also not actually less, it is this role of ISRO in the recent conflict that took place between, India and Pakistan. And they have, because of their success, we have been able to do such a good thing here. The topic of the last lecture is that futuristic defense technologies, can India become world leader? I think these are the 4 lectures we could organize with all the support that we got from our institute, and what is more important, with the support of all of you, our dear students, even including the school children. So in fact, you are the future and you can really do a lot and learn a lot. Thank you very much.
Thank you very much, Professor Achal. It's now my privilege to invite Professor Sunil Kumar Sarangi, who has served as the director of NIT Rourkela for more than 13 years, to kindly introduce our chief guest, Dr. V. Narayan, Chairman ISRO.
The distinguished scientists on the dais, off the dais, and the future distinguished scientists in big numbers in front of me. A warm greeting to all of you. Now, what qualifies me to be standing before such an august audience? I happen to be the professor of Dr. V. Narayanan, the chairman ISRO and secretary department space. And how it happened? Because I was teaching a subject called cryogenic engineering at IIT Kharagpur, uh, along with other colleagues in the department. And the year was around 1998, 1988, 89, that time. And ISRO had established certain amount of reputation, certain progress in propulsion technology, particularly solid propulsion, where you burn some chemical like something complicated, like ammonium perchlorate, things of that nature, or you use liquid propellants like unsymmetric uh, dimethyl hydrogen, nitrogen tetroxide, complicated substances like that. But there was a problem. The problem was, you imagine like this, you have to travel from here to Cuttack. What do? You take out your car and you fill it up with petrol and you drive, and you reach Cuttack and you still have petrol to come back. But you want to go to Delhi. What do? You take your car, you stop when your petrol is nearly over, then you refill it, go another 500 kilometers, refill again and reach Delhi. You want to go to the moon, you can do that. You go up to 500 kilometers, then refill, then another 20,000 kilometers. No, you can't do that. So only solution is you must carry all your fuel required from here to the moon or here to big orbit like 36,000 kilometer. Why 36,000 kilometer? That Dr. Narayanan will say. But to go to such far off places, you must carry a lot of fuel. And then your rocket becomes so heavy, it refuses to lift off. So it means it's a catch-22 situation. If you want to go too far, you need a lot of fuel. And if you put a lot of fuel, it becomes too heavy and it doesn't go. So the only remedy is to go for a fuel which is so smart that less mass can take it farther. And there are some complicated formulas beyond my brain power to figure out. But it so happens that the combustion products are at very high temperature and have a low molecular weight. The answers your chemistry professors would say, Professor Bose is right here. And if it has low molecular weight, the combustion product, and it is very hot, then it's a very efficient fuel combination, and that will take you to the moon. And that combination happens to be you burn liquid hydrogen and liquid oxygen, and then the combustion product is only H2O, water, and that's quite light. Molecular weight is only 18. and you add some extra hydrogen so that the average molecular weight further comes down. And then you can go to the moon, you can go to Mars, and you can go beyond. What happens is, unfortunately, liquid hydrogen has a temperature of 20 Kelvin, just 20 Kelvin, when the whole atmosphere will become solid, because oxygen becomes solid at 55 Kelvin, nitrogen becomes solid at 63 Kelvin, and hydrogen is liquid at 20 Kelvin, and liquid oxygen is 90 Kelvin. So if these kind of ultra cold substances have to be carried, special techniques have to be there. There has to be things of insulation, there has to be special worries about sealing, there is special about avoiding, pressurization buildup and so on, so on. And so that's the profession I was in. IIT Kharagpur has an exciting department called cryogenic engineering, where I was teaching. And you can understand, we had some exposure to such ultra low temperatures. And that was the time when ISRO decided to go to the third stage of rocketry development, go for cryogenic rocketry. That means use 20 Kelvin and 90 Kelvin kind of temperatures in the rocket body, set fire to it, produce hot steam, and propel yourself up. But then nobody in ISRO knew what to do. Nobody in the country knew what to do. We had to work together to learn and teach each other and learn in the process. That was a time when ISRO deputed a team of the best young people they had, and you can figure out somebody has to be among the best to be there. So we had Mr. Narayanan that time, Sri Narayanan, and his friends like Xavier, Kamatsi, so on, so on, who were deputed to IIT Kharagpur to learn few basics of low temperature engineering. And that is how we met. And it so happened that I was the supervisor of Sri Narayanan in 1988, 89, 90, that period, in his MTech thesis, where he worked on something called a cavitating venturi. I still remember the scenario of his final project experiment, where there is a huge quantity of liquid nitrogen flowing through a tiny plastic venturi tube, a converging, diverging nozzle, not the supersonic type, the soda one, where something happens. I am not your class teacher. You ask your physics professor to tell you what is a cavitating venturi is like. Now, my pleasant duty is to introduce Dr. Narayan. And if somebody asks you who introduced Dr. Narayan, you say Dr. Narayan's profession. That's my best introduction possible. Now, when I was a professor, I never carried a cheat to class, but my brain power has gone down, so I have brought a cheat. I'm going to read it to you, and it's very, very exciting. Dr. V. Narayanan, Secretary, Department of Space and Chairman ISRO, is a distinguished scientist in apex scale and is also the Chairman of the Space Commission. As the Chief of India's Space Agency, he provides techno-managerial leadership for achieving excellence in space transportation, infrastructure, and space applications, benefiting common citizens of our country, as well as creating and nurturing a vibrant space ecosystem in India. He is spearheading the complex, cutting-edge technology developments, feeding to national missions laid out as per the vision of the Honorable Prime Minister of India, like Gaganyaan program, Chandrayaan-4, Venus mission, Bharatiya Antariksh Station, next generation launch vehicles, and many more, including an Indian landing on the moon and returning safely. The country has already achieved the distinction of being the fourth country in the world to achieve space docking under the leadership, and he has successfully accomplished the 100th launch from Satish Dhawan Space Center, or SHAR, Sriharikota. Previously, Dr. Narayanan was the director of Liquid Propulsion Systems Center, the lead center for liquid propulsion development for all launch vehicles and spacecrafts of ISRO for a period of 7 years, having campuses at Trivandrum and Bangalore. As a director, he has provided able leadership in chemical and electric propulsion systems, control power plants, and transducers development for space health monitoring and built huge infrastructure. He was also the chairman of LPSC Propulsion Complex Coordination Committee overseeing the activities of IPRC. Dr. V. Narayanan had a brilliant academic career as he completed his MTech in cryogenic engineering with the first rank and Institute Silver Medal, and PhD in aerospace engineering, both from IIT Kharagpur, and has held key and strategic positions in ISRO for the past 41 years. He has played the lead role in cryogenic engine and stage development, which made India one among the 6 countries to have the coveted cryogenic capability and ensured self-reliance in launch vehicles. Dr. V. Narayanan, in his illustrious career, has been honored with more than 25 most prestigious awards, including Distinguished Alumni Award of IIT Kharagpur and a Life Fellowship Award also from IIT Kharagpur, Gold Medal from Astronomical Society of India, APJ Abdul Kalam Award, ISRO, ISRO Performance Excellence Award, etc., and awarded 2024 laurels for team achievement for Chandrayaan-3 by International Academy of Astronautics. Dr. Narayan is a member and a fellow of a large number of prestigious national and international scientific and technical forums, including Space Propulsion Committee of International Astronomical Federation, International Academy of Astronautics, and is a fellow and governing council member of the INA, Indian National Academy of Engineering, which Professor Acharya introduced to you, and president of the Indian System Society for Science and Engineering, etc. So I can go on and on, but I have copied only this much. Again, as I said, it is a great honor, great pleasure for anyone beyond a certain age to be introduced as the teacher, as the supervisor of a great scientist. It's my honor to be here, and thank you very much for listening.
As we proceed to the keynote address, now I kindly request all our dignitaries to please take their seat in the audience.
Very good afternoon to all of you. Most respected Damodar Acharya ji, the former director of IIT Kharagpur and the PhD supervisor of one of my mentors, Dr. Radhakrishnan, the former chairman, ISRO and Secretary Department of Space, and currently the chairperson of INA chapter of Bhubaneswar. My mentor, Guru, Professor Sunil Saranke, Dr. H.N. Ghosh, Director of NISR, Bhubaneswar, who is also a atomic energy scientist, former atomic energy scientist. Dr. Samantha Roy, INAE from IIT Bhubaneswar. My close friend and one of my critic, and we generally don't agree each other in technical things just like that unless both are convinced each other, Mr. Professor Padi from IIC, and he was also working with me a couple of places. We'll address in the appropriate time. We have fought enough each other technically. Personally, we are very close friends. And Professor Tiwari, Professor P.K. Misra, my friend, Deputy Director of LPSC Bangalore, Mr. Shampaya, and the faculty members from NISR, and my dear young students. It is a great honor and privilege that I stand in front of you in this wonderful auditorium to give the talk on the National Technology Day celebration. First of all, I have to thank a couple of people. But for Professor Sunil Sarange and Professor Acharya, truly I would not have got the great opportunity to be among you to do this talk. And let me thank them for the greatest opportunity. Because when you stand with the youngsters, you feel so young. Mentally, you feel so young. And that too, I was so happy to hear a lecture on free of cost from Professor Sarange, how the cryogenic rocket engine is important. I have heard long back, but then, that was long time. And what a fantastic teaching he was giving for 5 minutes before introducing me. And then, really, when you talk about National Technology Day, and I think our country, which got independence in 1947, today we have grown in all sectors, science and technology, health sector, infrastructure development, in agriculture production, milk product production, and whatnot. Every area we have grown. To be frank, when we got independence, none of the other countries would have thought that India will grow like this. Rather, they would have got doubt whether the Indians are going to really rule India properly. This would have been the great doubt. But please understand, it was not a single country, it was a princely states of so many princely states, and everybody is having their own kingdom. And then poverty was the order of the day, untouchability was the order of the day, and we were not having our own constitution. And at that point of time, nobody would have thought an average life of Indians were just 32 years. That means people were dying. No, what was the average life? 32 years means 25 years to 40 years is the lifespan of the people. And there were so many deadly diseases. And 97% people, now when you talk about poverty, I should tell, the youngsters will not understand. In my own village, 50% people only used to take food more than one time. And 50% people were taking only food in one time. This was the situation in most of the villages. And electricity. I think most of the villages, electricity was not there. Very few villages, electricity was there. We got electricity only when I was studying 9th standard. I still remember when we got electricity, that single day I would have switched on one bulb, some hundreds of times, switch on, switch off, and enjoyed. And you may not be knowing when we got electricity, my mother was telling, why are you doing this so many times? I was a student, 9th standard student, excited, switch on, switch off, switch on, switch off, enjoying. And there was no bus. If we had to go to the college almost 3 kilometers or so, we had to travel, then get to the bus. And that is the type of situation. And villages, nothing was there, no TV, no telephone connection. And you are seeing a different India today. India has grown to greater and greater heights. In 77 years of independence. Let us salute and thank all the leaders, visionary leaders and technocrats who are responsible for the great growth of this country. Let us give a big hand to all those people. And education, education is a fundamental right of a citizen. Hardly 2,825 primary schools only were there. Hardly 12% people are only educated, literate, not educated, literate, considered to be literate. And that was the order of the day. From that place, and science and technology, what I think we were nothing. There were no missiles, no space program, atomic energy program was nothing. And you imagine India without all these things, what type of India it was. And from that, today we have come to great levels. And the first Prime Minister of India, he has made a statement. I don't remember exact statement. Let me quote. It is science and technology only can solve the problem of poverty and hunger. Yes, it was true. And we had green revolution, we have white revolution. And today the country has grown and couple of places we have become world leaders. For example, take the software area. I think we are truly the world leader. We have come to a long way. And education, there were no IITs, no IIMs, nothing was there. That was the country status. And from there, we have come a long way. And the Bharat, the citizens has to be protected. And lot of things are done. And one of the things what is done is the nuclear explosion. And it is May 11th and 13th for its historical importance. 1998 is a historical day, second Pokhran. And the credit goes to a lot of people. That time the Honorable Prime Minister Atal Bihari Vajpayee was there. And in remembrance of that day, we are celebrating National Technology Day celebration. And today, I have got some connectivity. What is the connectivity? Indian space program was started in the year 1962. And there just was 2 pages appearing in the atomic energy budget paper that we have to have some space program and something has to be done. And first 10 years we were run, it was started by none other than the greatest son of soil, a visionary leader. And one of the richest person also, richest in economically, richest in knowledge, richest in character, Vikram Sarabhai. He strongly felt that advanced technology, space technology can be useful for the common man of this country in multiple areas. And a lot of people are not believing. And that was the program started. And up to 72, the activity was with the Department of Atomic Energy. Thereby, we have got a connectivity with atomic energy. And in 1972, Department of Space, a separate department was formed and it came out. And today, when we celebrate this National Technology Day, which has evolved into a flagship occasion, and this event will bring together policymakers, scientists, technocrats, industry leaders, academic institutions, and startup founders to deliberate and accelerate India's technological journey, and also put a strong foundation for the future technology growth of this country. And dear friends, if we are to talk about technology development in the country, I think starting from the railway system, starting from the automobile sector, there was a time, the car means only one Fiat car was there, if I'm correct, if my memory is correct. Nobody was having so many varieties, and then Maruti came, and today car means, in fact, I had to buy a car for my daughter. So much survey and finally confused which we have to buy. So many varieties of cars. There was a time, I still remember when I was studying the 10th standard, to see the aircraft. Now we had to wait in Thiruvananthapuram airport 1.5 hours to see an aircraft. And today almost every day I'm inside the aircraft. Okay. That is the type of thing, and the younger generations are enjoying. And the Indian space program has come a long way. And today I have selected the topic for my talk, the Indian space program, the pride of the nation. We started the space program almost 15 years after we got independence. And in fact, I want to tell, even though program was started in 1962, I completed my diploma and working in a company. BHL, you may be knowing, I was working there and I got the appointment order in ISRO. In fact, I want to tell so many people who are telling, don't join this organization. What for this is for this country. This is a statement made by so many people, educated people, some bank managers, my relatives, they were making a statement. And finally, yes, I joined in that organization. 41 years of journey, a very big journey in an organization and coming through a lot of people. And then getting an opportunity to study M.Tech in IIT Kharagpur, my guru is there. And not only she, there are so many teachers who have taught. So this talk, the Indian space program, the pride of the nation, first I want to dedicate on two people. One is my M.Tech supervisor, Professor Sunil Sarangi, and the PhD supervisor, Professor B.N. Sridhar, a person of great stature and this one, he is no more with us. And with that introduction, before I go through the talk, a lot of young people are there. I thought it is appropriate, instead of going on talking, you should really enjoy the talk, Continuously somebody is talking high technology field, you should not get bored, and finally you should not lose interest. What I thought was, my talk will have three parts. First portion, a 9-minute video about Indian science and technology growth and how the ISRO has fit in. A 9 minutes video, followed by couple of slides and my ideas, maybe some 40 minutes, 45 minutes, I will talk. Then followed by a conclusive video, because all youngsters, when you go out, you should enjoy the talk, enjoy and carry forward something. So with that, so first let me go through the first video. Let's see this. Video number 2. So let us see the first video. After that, I will come and talk with you. Yeah, so you enjoy the video, then I will come back and talk. No, audio. Please, with the audio maximum, please close. Maximum audio.
Dawn of civilization, India has gazed at the stars, not just with wonder, but with wisdom. From the pages of ancient scriptures to the launch pads of modern space missions, India's journey through science has been nothing short of extraordinary. Long before the world understood the language of numbers, Aryabhatta in the 5th century unveiled the concept of zero, a discovery that would forever change mathematics. He calculated the value of pi and proposed that the Earth rotates on its axis. During the 20th century, a new wave of Indian scientists emerged. Visionaries like C.V. Raman, Homi Bhabha, and many others who made groundbreaking discoveries. Their work laid the foundation for India's modern scientific renaissance, bridging ancient wisdom with contemporary innovation. In the 1960s, amidst a newly independent nation, one man envisioned a future. He is Dr. Vikram Sarabhai, the father of the Indian space program. He believed that space technology could transform the lives of millions. The Indian National Committee for Space Research, INCOSPAR, was established in 1962. In an extraordinary act of generosity, the St. Mary Magdalene Church in Thumba became the birthplace of India's space dream. The Thumba Equatorial Rocket Launching Station, TERLS, was set up, paving the way for India's first sounding rocket launch on November 21, 1963. In 1969, INCOSPAR evolved into the Indian Space Research Organization, ISRO, with a clear mission to propel India into the global space race. And just 6 years later, in 1975, under the leadership of Prime Minister Indira Gandhi, India launched its first satellite, Aryabhatta, in collaboration with the Soviet Union. This marked India's entry into space exploration, and was a crucial milestone for ISRO. But space was never an easy frontier. The SLV-3 mission in 1979 failed. Yet, in adversity, ISRO found resolve. A year later, under the leadership of Dr. Satish Dhawan, then chairman of ISRO, India successfully launched the Rohini satellite using the SLV-3, marking its entry into the exclusive club of spacefaring nations. In 1993, under Dr. U.R. Rao's leadership, ISRO launched the PSLV, which became India's reliable launch vehicle. Further, ISRO launched various types of satellites, including communication, Earth observation, navigation, and scientific research satellites. These support vital activities such as telecommunication, weather forecasting, disaster management, GPS navigation, space research, environmental monitoring, and agricultural monitoring. In 2008, India took a giant leap with Chandrayaan-1, discovering water molecules on the moon, an achievement that stunned the world. In 2013, India launched Mangalyaan, its first interplanetary mission to Mars. Against all odds, India became the first country to reach Mars on its maiden attempt. With the GSLV Mark III in 2014, India now had a powerful heavy lift rocket. This paved the way for Chandrayaan-2 in 2019, a mission that, despite hurdles, brought valuable lunar insights. In 2017, India became the first country to send 104 satellites together. In 2020, Indian government initiated major space sector reforms leading to the establishment of the triad partnership between ISRO, InSpace, and ENSEL, helping India transition from a government-driven space program to a public-private collaborative model.
Five, four, three, two, one, zero.
On August 23, 2023, India made history. Chandrayaan-3's Vikram lander touched down near the moon's south pole, making India the first nation to land in this uncharted lunar region. From scientists in mission control to school children in remote villages, the entire nation celebrated as one. In 2023, the successful RLV-LEX reusable launch vehicle landing experiment test marked a major milestone in India's journey toward developing a fully operational reusable space shuttle. On September 2, 2023, India looked beyond the moon and towards the heart of our solar system. Aditya L1, India's first space observatory studying the sun. In 2024, India embarked on an even more ambitious mission, the SpadeX, Space Docking Experiment. SpadeX showcased India's mastery over orbital rendezvous and docking technology, a skill only a handful of nations have achieved. This is not just an experiment. It's a glimpse of India's space future, where Indian astronauts will one day dock at our space station. With every mission, India is not just launching rockets. We are launching possibilities. An era we call Amrit Kal, the age where India's cosmic ambitions will soar beyond the stars. A new dawn has arrived, a golden era of space exploration. Recently achieved the milestone of 100th launch in January of this year with the launch of GSLV F-15.
This mission is the 100th launch from our launch pads, which is very significant milestone of India. Our space program was conceived and started by visionary leader, Professor Vikram Sarabhai, and taken forward by generations of leaders.
As we march toward 2047, India's 100th year of independence, we unveil a vision where India leads the world in space exploration. Driven by cutting-edge AI that propels innovation and intelligent solutions for humanity's greatest challenges. In 2025, for the first time in history, India is planning to send its astronauts, Gagan Yatris, to space aboard an Indian rocket launched from Indian soil. It is about inspiring 1 billion dreams and proving that the sky is no longer the limit. In 2028, Chandrayaan-4 is slated to mark a historic first for India, a lunar sample return mission. These samples will unlock the secrets of our celestial neighbor and pave the way for future human exploration. With Chandrayaan-5 and the LoopX mission, we take our next step, searching for water ice at the moon's poles. Because where there is water, there is life. And where there is life, there is the future of human settlement beyond Earth. To reach beyond, we need a new kind of rocket. Introducing the NGLV, India's powerhouse of the future, capable of carrying humans, space stations, and interplanetary missions. Reusable, efficient, and built for the next century of spaceflight. If Earth had a twin, it would be Venus. In its Venus Orbiter mission, India will send its first mission to Venus to study its climate and atmosphere and unlock the secrets of planetary evolution. By 2035, India aims to establish its own space station, Bharatiya Antariksh Station, a floating laboratory, a gateway to deep space, a new home for humanity beyond Earth. Through its missions, India stands as a beacon of sustainability and collaboration, pioneering a vision for debris-free missions that ensure responsible and sustainable space use for generations to come. The greatest milestone of all, by 2040, India aspired to send its first humans to the moon, a dream once seen by visionaries like Dr. Vikram Sarabhai and Dr. APJ Abdul Kalam, will finally come true. By 2047, when India completes 100 years of independence, we will be a global space power, leading humanity beyond Earth. The future is Indian. The future is cosmic. The future is now. Jai Hind, Jai Vigyan, Jai Antariksh.
Go to the presentation. Yeah, I think hope you enjoyed the video. Now probably you can switch on the lights. And now we'll go through the presentation. And the need for space-based system, Sarabhai strongly felt at that point of time it should be second to none in the application of advanced technologies to the real problem of the man and society. And nobody thought at that point of time we will have human space flight programs. And we were not competing with any other country. The space program was purely designed and conceived for meeting the requirement of Bharat and the citizens of the Bharat. And to bring the advanced space technology for the common man, we need satellites of different capabilities, different varieties. And can you switch on the light? Let me see the audience. Please switch on the light. So satellites of different types. Then to place the satellites, we need launch vehicles. And for sending the satellites to the space, we need ground equipments. Also for utilizing the satellite data for the common man, we need to have ground equipments. In fact, all the developments were started simultaneously and concurrently. And if you look at the space activities, the Honorable Prime Minister himself is the Minister for Space Activities. Then we have got ISRO, the prime R&D activity area, where we deal with the launch vehicles, satellites, application, planetary exploration, and so on, and human space flight program. And there are 13 centers and units. We have got autonomous bodies, and we have got the in-space system for promoting, hand-holding, and authorizing the private space activities. And we are having commercial wings. And the sanctioned power is something around 20,000 employees today as on date. And our annual budget is 13,500 crore. And approved projects are 1,30,000 crore. Out of that, almost 90,000 crore has to be utilized. And if you see, we have offices, 43 offices across 22 locations in the country. And the activities also supported by almost 450 industries across Bharat. And we have splitted the entire activities into 5 verticals: space transportation, which deals with the rocketry and related technologies; space infrastructure, which deals with the satellite and associated technologies; space application, and human space flight activities, and capacity building. And the entire activity was started. The brainchild work was done in the year 1961. Professor Sarabhai, along with people like Chitnis, who is going to be 100 years by this year, July, living in Pune. And they thought that better to have a space program in the country. And Professor Chitnis clearly told, very openly told, I had the opportunity to take his blessing a couple of months back in Pune. At that point of time, when they were discussing, any sort of analysis would have been done, the space program would not have been started. Yes, economically, you cannot simply justify. And our knowledge was very, very low. And then it was a determination, commitment, and innovative thinking which started the program. And this program was started in 1962. And there are major milestones. 1963, November 21st, we had the first launch of a tiny rocket from Tumpa, the Indian soil. That rocket doesn't belong to us. It was an American rocket, and a sodium vapor lamp came from France, assembled in the country, and it was launched. And 20th November 1967, just we were not having any propellant. We borrowed from Aravangad Defense Factory, from Karodite, and it was put in a barrel, and we had the first launch. And at that point of time, then of course, 15th August, ISRO was formed, and 1972 Department of Space was formed. 1969 is an important year. What is the importance of that year? Neil Armstrong landed on moon, and he has come back safely. And 1969, if they were to land, the activity would have started in 1960s. Itself, there was a Cold War, and activity was going in a big way between two countries, and they landed. And at that point of time, even we had not started the activity. And we were truly 70 years behind the advanced countries. If you give a PhD status for those countries, we were not even in the LKG, just we were in the play school level. From that, and you can see the people carrying rocket parts in bicycle, old bicycle, tying with rope and carrying, that is the stature of the country. We are 70 years behind. And from that, today we have come a long way. And something around, there are different types of sounding rockets are realized, starting from going to 85 kilometers to something around 600 kilometers. Something around 4,006 sounding rockets have been lifted off from Indian soil, doing a lot of activities. And then came to the launch vehicle development. Launch vehicle, the first launcher was the SLV-3. And the project director was none other than APJ Abdul Kalam. He was the project director, and the chairman at that point of time was the great leader, a institution builder, Professor Satish Dhawan was the chairperson. And it was in the year 1979 we made the first attempt, but unfortunately the mission could not be succeeded. And second launch attempt in 1980, July 18th, July 1980, we succeeded and India joined one among 6 countries having that elite group of nations having that satellite launching capacity. But please understand, when we are putting 35 kg, the world capacity is 125 ton is the capacity of the world, and where we are standing. So from that humble beginning, we have come a long way. Then, of course, we got the next rocket, the augmented satellite launcher, capable of placing 150 kg. Then we had a lot of setbacks, and we learned the technology in a hard way. And satellite launch vehicle technology is amalgamation of all branches of science, all branches of engineering, and we have to sit together, understand control, guidance, materials, aeronautics, mechanical, materials, everything we had to master at that point of time. Today, if you look at to our credit, we have conceived, designed, and realized 6 generations of launches, and SLV and ASLV was experimental vehicles, and PSLV, GSLV, LVM3, and SSLV, these 4 are today operational vehicles. And the year of the first launch is given, successful launch is given there. And in the area of spacecraft, it was in the year 1975, exactly 50 years back, April 19, we launched the Aryabhatta satellite with the support of Russians. They supported us in a big way in building the satellite. Understanding got generated through the interaction with them, and they only launched. The country was not having neither launch vehicle area technology nor satellite technology, and nor strong ground-based supports. And from that, if you look at over 50 years, now we are celebrating 50 years, we have conceived and built from around 132 satellites. And the heaviest satellite is the GSAT-11, around 6,000 kg is the satellite mass. Right now working fantastically well in the orbit, and we are having, to our credit, something around 56 satellites in the orbit, serving the common man of this country in multiple domains, various domains, including the ensuring the safety and security of the common man of this country. In the area of application, it was exactly 50 years back, 1975, the SITE experiment, satellite instrumentation and television experiment was demonstrated. 2,400 television sets were kept in 2,400 villages, and the signal from ATS-6 satellite was transmitted through that and demonstrated to the country that mass communication is possible. And that was the largest sociological experiment in the world, and we are going to celebrate 50 years of that celebration. And from that, today, in 50 years, we are having almost more than 50 applications for the common man of this country. In the area of food security, environmental monitoring, land and water resource management, ocean application, forest cover mapping, potential fishery zone mapping, meteorological, and coming to SATCOM application, television communication, TV broadcasting, tele-education, telemedicine, radio networking, and so on. NAVIC application. Today, we are connecting something around 8,600 locomotives and real time. Dear friends, there was a time, if some of your relatives are coming by train, you don't know when the train reaches, you go to the railway station, you have to wait. Today, everything is in the, you can connect, you can understand from where it is coming. I still remember when I was a student in IIT Kharagpur, between the railway station to IIT, 4 kilometers, and we had to go and sometimes wait 8 hours to get the train. We were not knowing what is happening. Today, that is not the situation. And in the area of disaster warning and mitigation, I think Odisha is one of the area which affected in a big way in some of the disasters. And you know, what is the value of individual human life? It is price cannot be. It is so much value you cannot estimate. And we used to lose thousands of our citizens. Probably people are not bothered so much at that point of time, maybe because of huge population, I don't know. And the value of human life is so precious. And today, through our system, we are in a position to save a lot of lives. In the area of strategy application, India is a country who are not having very friendly countries as neighbors, unfortunately. And you know, I need not explain. And we are having 11,500 kilometer seashore area. We don't know what will happen from where. And it is that area we have to monitor and we have to provide safety and security. I think satellite is one of the important system which is essentially required. Now, of course, I have put a couple of applications. I will not go in detail. For example, real-time train monitoring, almost 8,000 locomotives you are monitoring. Vessel communication, 21,000 vessels are real-time monitored. And telemedicine. We are having 180 telemedicine nodes and distress alert. We are having a system, even we are supporting other countries. Last few years, almost 2,150 lives are saved. This is apart from the regular disaster mitigation plans. And flood monitoring, and forest fire monitoring, and so many areas we serve. I think I'm not going to talk much on this. And the entire space activities last 63 years accomplishment is placed in a single slide for your understanding. And we had got built the end-to-end mission application capabilities built in the country. As I told, 4,000 plus sounding rockets are lifted off. And through private companies, 2 suborbital flights are accomplished. And something around 132 satellites are built and 101 launch vehicles are built and launched. And if you see the growth, the bottom 2 graphs are very important. Exponentially it is growing. For example, 2006 to 2015 launch vehicle missions were hardly 30 numbers. And next 10 years, it is just becoming double. And satellite area also, it is almost a similar case. And 36 to something around almost 61, 62 numbers it is becoming. That shows the exponential growth in this area. And now coming to our launches, the PSLV is a workhorse. And till today, we have launched 63 launches, and first successful launch was 1994, October 15, was the first successful launch. The first launch was 1993, it was unsuccessful. And recently, 101 launch, that is the 63rd vehicle. Unfortunately, there was a small problem. We could not successfully accomplish the mission. Doesn't matter. This vehicle has placed something around 64 tons of payload in the orbit and serving the common man of this country. And so many varieties of payloads. Earth observation satellites, navigation satellites, student satellites, Mars orbiter mission, I will come back little later, SpaceX, OM experiments, lot of things it has done, and through a single rocket, 104 satellites are placed in the orbit. And the typical launch. Coming to the next vehicle, the capability of this vehicle is almost 2 times of the PSLV, called the GSLV Mark II vehicle. This had all sort of propulsion system, including the cryogenic propulsion system on the top. And here, the cryogenic propulsion system, we know the development will take almost 15 years. We are looking for the technology from other countries, and finally, due to geopolitical reason, the technology was denied. So initially, we procured a couple of hardware from Russia, then USSR, and mission management system we developed, basically electronics and instrumentation and control system we developed, and jointly we operated, and we have done something around totally 6 flights till today. Subsequently, we took the indigenous development. 1995 project was approved, and almost 20 years we had to struggle and work hard and hard. Lot of setbacks, lot of learning, exponential growth in the learning process. And finally, we succeeded in January 5th, 2014. We succeeded. 1995, the program started. And coming to the Mark III vehicle, this is again a game changer. It's a totally a new vehicle. There are 2 solid propulsion systems on either side, each having 206 tons of propellant load. And center there is a liquid propulsion powered by 2 Vigas engine, each generate 80 ton thrust and 110 tons of propellant loading. And upper stage is a cryogenic stage. So 3 times powerful stage than the Mark II stage, totally indigenously developed without anybody support, anybody hand inside. And till today, we have done 7 missions accomplished. All 7 missions are successful. Mark 3, all 7 missions are successful. And you can see some of the test of the core liquid stage and the bottom is the solid motor. Please understand it generates something around 650 tons of speed thrust. It generates the solid motor. And in the solid motor development today, we are in par with any other countries in terms of performance. Maybe size, our need has not come. Otherwise, in terms of performance, we are in par with any other country. Coming to the cryogenic stage, we have successfully developed the cryogenic stage. I will come back a couple of achievements later. And this is 3 times powerful than the Mark II cryogenic stage. And what you are seeing is here, testing in a test tank for about 1,000 crores of money. This is a total stage undergoing test. We are having a liquid hydrogen tank, liquid oxygen tank, and the entire system. It's a very, very complex system. I don't know, dear friends, whether you observed when we were lighting the lamp. Whether you noted each just how much time they took to light the lamp. And in the cryogenic system, we are having liquid hydrogen. First it is admitted, then we are admitting liquid oxygen. Both are at extremely low temperature. And I still remember the low temperature when Professor Sarangi was explaining when I was a student. It has to be stored. Hydrogen is at minus 253 degrees centigrade. You know what is 253 degrees centigrade? Can you get a feel? Water is at 30 degrees centigrade. Simply you heat another 70 degrees, you rise 100 degrees centigrade. When it is boiling, you try to put your hand inside and hold for some time. Then you will understand what is the 70 degree rise. Here from 30 degrees, if you go to lower at 0, ice will form. Simply assume the entire room is ice and you are standing on that, you know what will be the ice effect, you will understand. From there, another 253 degrees, we have to go down and produce liquid hydrogen in the liquid form. And hydrogen oxygen is the most efficient propellant, chemical propellant combination. Because as the professor told, higher temperature and lower molecular weight combination. And this hydrogen has to be produced, even ice is there, simply you keep it, it will melt and go. And this will not stay. And we have to store in containers with 10 power minus 6 watt per meter Kelvin equivalent thermal conductivity, 10 power minus 6. The conductivity of stainless steel is something around 20 watt per meter Kelvin. And when Professor Sarangi was explaining, one day he asked, can you just give a feel of what is this 10 power minus 6 watt per meter Kelvin? And none of us could give a physical feeling. Then he gave a physical feeling. And he asked us to calculate and understand that, what was the physical feeling? Thermos flask. Who are all the people who have seen thermos flask? Can you raise your hand, students? So, I am very happy that most of you have seen. And you have used. And if you keep water in the thermos flask, hot water, boiled water, maybe you can use in the hot form, maybe 24 hours, 30 hours, you can use. Beyond that is gradually to lose it because of the thermal conductivity, thermal problem. The temperature will come down. And if you are having a vessel with 10 power minus 6 or minus 9 watt per meter Kelvin and keep coffee inside or hot water inside, you can serve that hot water for your granddaughter's wedding. This is what he gave the explanation and he asked us to explain, understand. And yes, that is the type of technology what has to be developed for storage, production, storage, and everything is complex. That's why otherwise every country would have developed. And today, I am very happy a technology which was denied. We are one among 6 countries having 3 cryogenic stages, Mark II, Mark III, and for the human-rated vehicle, we have developed another powerful stage. Right now, it is in the Sriharikota range. We have done an Astrosat mission, India's first dedicated space astronomy observatory in the space, which was accomplished by PSLV C-30 vehicle. And dear friends, in the initial phase, when we were 60, 70 years behind, the rocket parts were tied in old bicycle and moved for launch. Old bicycle, we were not having enough vehicles to move. And the first communication satellite, Apple, for an experiment, the experiment was enabled by moving in a bullock cart. And you can Google, you will see bicycle and bullock cart. These are all not cartoon figures, it is actual photographs. And from that era, we have come a long way. Today, couple of places we have become #1 position. Chandrayaan-1 is our first interplanetary mission, and which found water molecule on the moon. And India is the first country which found water molecule on the moon. None of the other countries found water molecule on the moon, and made every Indian proud. And Abdul Kalam ji, a person with a different thinking, he used to tell, unless you go and register your land, and after sometimes these advanced countries, the fellows will not allow us to go to moon, and they will say entire country, entire moon is theirs. So we put a moon impact probe by that mission. And Mars orbiter mission, we have to go to red planet to study the red planet. Something around 68 crore kilometers we have to travel and go to red planet. 68 crore kilometers. Please do a simple calculation with 0.01 degree error. If you go where you will go, you will not go to red planet, you will go to some other planet. And we have to go there and operate another engine after 297 days, developed by my own center, where people like Chambe, all the people are involved, and we have to operate and capture after 297 days. And it was successfully done. And India is the only country till today, only country, and the first country we accomplished a red planet mission and succeeded in the first attempt. None of the developed country has done in the first attempt. Not only that, it is a very, very low cost mission. We use the operational PSLV vehicle, and per kilometer travel, what is the money spent? It is lower than auto fare. That is what is Indian, and Indians are famous for accomplishing with low cost. And coming to Chandrayaan-2, it was supposed to be a lander mission, but we could not soft land in the first attempt. And we are having an orbiter in the moon's orbit, having 8 payloads pumping so much wealth of scientific data about them, so much wealth. One has to take the data and do research. We are having a camera called on-orbit high-resolution camera. The resolution is 32 centimeters. This is the best camera available as on date in the world in the moon's orbit, and that belongs to India. And Chandrayaan-2, we could not succeed in the first attempt. And I think my friend, where he has escaped now, Professor Badi, I think he was somewhere here. Where is he? And I think he is required here. Actually, I want to tell, a 10-member committee was constituted to study the reason for the setback. And we were given 1 month time to study. And there were 10 members. Padi was one of the members, and I was the chairman of that committee. I still remember, because this technology of satellite technologies, so many things has to be done: navigation, guidance, control, so many things. And on the 8th day of the meeting, first I gave one guideline as the chairperson. None of the people can go out from ISRO headquarters without submitting the report. This was one direction given here. All members have to stay back. And the meeting goes up to night, 12 o'clock, early morning, 2 o'clock. And whenever we feel tired, only we go to the room and sleep and come back. 24/7, the work was going on. And one day, I have set the target of reviewing navigation, guidance, and control. And morning, I am getting up and getting into the vehicle. I was not confident as the chairman to review, because people with 35 years of experience with PhD degree from higher institutes like IITs, IAC, they are going to present. And my knowledge was not even LKG standard as the chairperson. Of course, Padi was knowledgeable. But then, if you miss anything, it is not missing. Next flight, Chandrayaan-3 will be a perfect, assured failure. I still remember morning I got into the vehicle. 9 o'clock, I called my member secretary. I told, please cancel the meeting. The meeting was supposed to start 9:30. Then I called Padi. I asked, where are you? Then he told he is just coming out of the institute for the meeting. I told, don't come out of the institute. Please be in the institute. I am coming to your place. I reached there. I know he had a presentation, not presentation, a course material. He was teaching control guidance and navigation control and guidance. And went and told, you are going to teach me, I am going to hear you for 6 hours. But don't teach the advanced high funda equations. Teach fundamentals on navigation and control, guidance and control. I still remember the class went up to morning 10 o'clock to evening 3 o'clock. By that time, I got some sort of grip on the topic, basic logic. Padi, we are talking about you only, your class, you are teaching. And You know, Padi, if you ask him to teach, he will put all high funda equations, you will not understand ABCD of it. Only PhD people can understand, not people like us. But then I ensure that I requested him not to. Whenever some equations are coming, I will tell skip. And without equation only he has to skip. Because a subject which he has to take class for 6 months. In 6 hours, he has to teach me how to understand. And he was teaching. This was fact. By 3 o'clock evening, we both, and he gave a very nice lunch also. Teaching and giving lunch also he gave. And then both of us, by 3 o'clock, we went for the review. And review started 3:30. Dear friends, I want to tell, in 20 minutes of the review, the failure was pinpointed. There was a problem inside. And you please understand, the people who are not that knowledgeable with this knowledge going, and in fact, when it was presented, first the presentation was made, I asked my friends to, and people are presenting with PhD qualification and very strong funda they are presenting. A slide was put to the, then I told, can you explain the logic? They told, sir, it's a highly complex equation. Because they know I am a mechanical engineer, poor guy, nothing, I will understand. Do that only they are talking. I told, no problem. You please explain the basic logic. When the basic logic was explained, fundamental mistake inside. Within 20 minutes, it was pinpointed. And that is the ability of ISRO team to understand and come back. And today, we have in exactly 1 month time, we have completed this is only one story like that. There are so many stories during the FAC, conducting the FAC itself. And thanks to Padi. And in the meeting, we used to fight each other. He will not agree whatever we are telling. We will not agree whatever he is telling. Finally, somebody has to convince and put him down, and or he has to convince us. And finally, it is the teamwork which matters. And the team gave 107 recommendations. And today, dear friends, 107 recommendations. Average sleep of 10 members for 1 month was 3 to 4 hours only. And with that 1100-page report with 107 recommendations was submitted exactly on the 30th day, 5 hours before the deadline. And today, it is a history. Out of 107 recommendations, 106 were implemented and a lot of tests were done. And the Chandrayaan-3 was a grand successful mission. And the credit goes to a lot of people, but this committee also has lot of work we have done. And then understanding. Actually, we used to tell one thing, one of our director, Vasandaji used to make one statement. You know, who are all the good engineers? Good engineers are good monkeys. And we used to think, what he is talking? Good engineers are good monkeys. He is comparing us with monkey. And then he politely was telling, you know, monkeys, what they do? If it has to climb to one tree, it will climb from bottom, it will go up to the top. From that tree, if it has to go to next tree, it will not come down and climb. It will, from there, it will jump. And good engineers, your foundations are strong. If you are a good mechanical engineer, to understand electronics, you need not come down. You can little bit jump. And to understand software, in fact, 1 lakh, one more thing I want to tell, 150 line softwares. And we can understand, you know, where the problem has happened. And I still remember when we were reviewing the software, we asked the people to load the flight software. And they were really understand what the fellow will understand and loading the flight software here. And then we asked them to go to the right place. In fact, I was telling you go to this place and explain ADA language software. Within 7 to 8 minutes, mistake was pinpointed. What was the mistake? So what is required is a basic commitment and understanding, interest, and we can do. And then coming to Chandrayaan-3,
At this point,
we have
are providing confirmation
indicated
of the
August was a
safety of the
very, very
landing site.
important day.
As
The
expected,
Chandrayaan-3
the
was detected
retargeting is going on,
6,077
and this is a
kilometers per
very
hour,
good signature
8
for
times
the
of
lander.
aircraft speed, and
अभी आप ये
every
देख
Indian
सकते
can be
हैं
proud
कि
of
लैंडर की ऊंचाई
successful
लगभग
mission.
65 मीटर के आसपास बची हुई है.
And Honorable Prime Minister was watching from abroad, and it was a day of excitement, entertainment,
Currently, only
and a
2
satisfaction
engines are now being
which we have
fired,
done.
and we are nearly
of
at
achievement. I think I will
zero
skip the
velocity.
video. And then today it is history. India is the only country, thanks to some of the countries which attempted just 1 week before our landing. And India is the only country and first country which has soft landed near the south pole of moon. Can you imagine a country which got independence only 47 has done it? And so many discoveries we have done, and lot of discoveries, I am not going through that. And the next Aditya India, to study the sun. You know, there are so many countries. How many countries are there in the world? So many countries. And we are the fourth country to build a fantastic satellite called Aditya L1, taking to 15 lakh kilometers and commissioning there and making it successful. And today, we have got wealth of data, 7 terabit wealth of data is there. The 7 terabit data is there. And you can see video, actually you should go through the data, and we have put in the public domain for scientists to study. And the mass ejection, you see the video, how the mass is getting ejected. And lot of things are there, understanding is there. And we have got a space capsule recovery experiment. And here I want to tell, dear students, when in the main gate, if you are allowed to get down and your eyes are closed and you have to go to your classroom, how many of you think that you will succeed and directly go to the classroom and occupy your seat? I don't think any one of us will occupy that seat perfectly. We may go to some other classroom or somebody else seat, all drama will happen. And here, an object which was rotating in the space, and after so many days, it was brought and landed perfectly in a place automatically, autonomously, with control, guidance, navigation, aerodynamics, entire thing coming inside, precisely landing in the same place with the first attempt. And Gaganyaan program, we are going to send our own Gaganyaan 3s to space, and towards this, lot of activities are going. The vehicle has to be developed, the environmental controls and safety system which has to maintain carbon dioxide, oxygen content, everything under the required levels, and temperature, relative humidity, pressure, everything has to be developed. And there are set of parachutes, 9 numbers of parachutes are required towards the end to soft land. And there are health monitoring system. Continuously, you have to monitor the health of the vehicle and associated system that is required. And the vehicle will take you to something around 170 kilometers. From there, you have to take through another set of propulsion system. You have to take it to 400 kilometers and keep them safe, controlled properly. And after a few days, you have to bring them down by reducing. Actually, going is tougher and bringing them down is again very tough because you have to reduce the velocity and lot of heat flux will be generated, thermal system development, lot of work has to be done. And today, something around, I will say, 75 to 80% work is successfully completed. And now we are going for, and you can see, you can read, so many development has to take place, even human-centric products, their food, their waste disposal system, then food, and so many things has to be developed. And it is a national project, DRDO, and again, mission management at the end when they land, Air Force and Navy, their support is required because we don't know exactly where they will land. And in case of any emergency, they can land in other parts. So many systems has to be put in place, and we are working towards that. And we have also demonstrated the crew escape system. Suppose when the crew is inside, and if anything happens to the vehicle, we cannot kill the crew, and we have to save them through a system called that on the top, whatever you are seeing, the crew escape system. And lot of experiment and simulation has to be carried out. And we have developed a exclusive vehicle, and we have taken the crew module to required altitude and simulating the abort condition, and it was landing. We have to simulate multiple times. In fact, one test we have done, and second test is planned. Maybe another 2 months, you will understand TVD2. And exactly it was all parachutes deployed, and it went and landed near Chennai. And our Navy ship Sakti went and picked up. And we went and got the product like a brand new product without any problem. We got the product back. And these are all the parachutes which is getting deployed. And so much development. And right now we are working to have the first uncrewed mission this year. And instead of human being, there will be a Biomitra which will be flown. A humanoid will be flown. And then 2 more uncrewed missions we are planning next year, followed by 2027 first quarter, we will have the crewed mission. Now, 1984 was a historical year for India, and we sent our Rakesh Sharma ji to space. And you would have heard that famous conversation between Prime Minister and Rakesh Sharma. And he's with us working, transferring lot of things, ideas for the Gaganyaan program. Now, on 8th of next month, mostly 8th of next month, we are going to send one of our Gaganyaan 3 to International Space Station to gain some experience. And now lot of programs, 8 missions are targeted with 20,000 crore budget. We are going to have 2 crewed missions. Then we are going to build a space station, and we are going to have docking experience with the International Space Station as well as our own space station. We are going to have experience. And coming to the future, lot of new development works are going on for enhancing the payload capability of our vehicle. We are developing a new engine called, which is working with liquid oxygen and kerosene, refined kerosene, a 200-ton thrust engine. This is the highest thrust liquid engine ever developed in this country. And right now, the research work is going on in the advanced level, not research, testing level is going on. And in fact, last month in a 1,000 crore facility, we have successfully accomplished the first test, and we are going to have this mission maybe in another 2 years time frame. And then upper stage also we are improving. And this is the facility, a 1,000 crore facility, what you are seeing, which was dedicated to the nation by Honorable Prime Minister last year. And we have done the first test. And coming to another important thing, docking experiment. And 2 satellites rotating with a velocity of 28,400 kilometers per hour. Now we have to dock. We have to join in a software using a set of hardware and software. This was done on 16th of January. And India becoming one among 4 countries demonstrating this high technology, which is necessary for future programs. Our first launch, we could not succeed. And second launch was successful. And the 100th launch we attempted, we had on January 29. And it was a grand successful mission. And in Indian space program, we have written the golden letters, the successful launch of this 100th launch. And of course, one not one, we faced a problem. And then we are in the process of understanding and appreciating and coming back. And this is the vehicle, the most complex vehicle, accomplished that mission, the GSLV Mark II vehicle. I think I will move. And world records. A country which was tying rocket in a bicycle. Today, 9 places we are number 1 in the world. As I told, the Chandrayaan-1 finding water molecules, Chandrayaan Mars orbiter mission accomplishing the first mission, and 104 satellites going in a single go, and highest resolution camera, successful soft landing near South Pole of Moon, and finding lot of discovery in the South Pole. These are all the major number 1 position we have got. And the cryogenic technology, whatever denied to India, we have got 3 places, number 1 position. That is what is displayed in the slide. And with just 3 engines, as compared to 7, 8 engines of other countries, we have completed the first successful mission, and we have got number 1 position in the world. And just in 28 months, against 37 to 108 months, average of something around 60 months, the world record, we have accomplished this mission in just 28 months from the engine test to flight, and we have got number 1 position in the world. And a stage hot test, which was done in just 34 days using hydrogen, liquid oxygen, against world average of something around 6 months, and minimum of 68 days is for a small stage, and people have taken up to 10 months, and we have got the 3rd world record, and a technology which was denied to India. And today India could make 3 places world record, and we are standing tall because of our dedicated and systematic effort. And Aditya alone, we are one among 4 countries. SpaceX, we are one among 4 countries. Cryogenic technology, we are one among 6 countries having that carded technology. And India space vision is a history we are going to generate. Lot of missions are planned under the visionary leadership of the Honorable Prime Minister, who is the Minister of Space Program. And we are working on a new generation launcher. The capability of the launcher is something around 30 ton to low Earth orbit. First launch vehicle capability was only 35 kg. It is 1,000 times more than that capability. We are working towards that. Lot of development, including a LOX methane propulsion system for reusable system, is also getting developed. This vehicle, like SpaceX, the first stage will be a recoverable stage, and towards that a lot of work is happening. And coming to the India is going to have its own space station, as you have seen in the video. By 2035, we'll have our own space station. And it will be a 52-ton mass space station with 5 modules. And the first module will be lifted off in the year 2028. And we are already in the process of realizing a couple of hardware. And We are already Honorable Prime Minister has rolled out the space sector reform. We are enabling the ecosystem, space ecosystem to grow in the country, involving students and startup companies and academia. We have launched 344 satellites of 34 countries from India. 344 satellites of 34 countries from India using Indian launcher. And lot of new programs are approved. Chandrayaan 4, what is a sample return mission to take sample from moon and bring back to Earth. You can see the mass, something around 2.5 tons of Chandrayaan 3. And we are working on Chandrayaan 5. It is a heavy lander. JAXA and India is working together. You know, there is a statement, strength respects strength. When we succeeded Chandrayaan 3, Japan wanted to collaborate with us, and it is government of India has approved, and we are working on this program. Venus orbiter mission, we are going to have a mission for Venus. And vertical takeoff and landing for recovery the stage, lot of experimental work is going on. And for taking man to moon, the program is not yet approved, we are studying the configuration. We are trying to build a rocket, configure a rocket with 120-meter height. 120-meter height is equivalent to 40-story building. You imagine, I don't know the country whether we are having 40-story building, I'm not sure. And 40-story building height with 2,700 to 3,000 ton lift-off mass. This vehicle is configured just in 1 month time frame. And we are going to have a Mars lander mission. We are working towards that. And reusable launcher technology. In fact, you saw that video of how it is coming and landing. A technology demonstrator was done. Now we are working on the actual reusable system. And you know, to make it successful, aerodynamics, I think people like Ravi can understand much better than me, because aerodynamic control, guidance, everything has to get married together, and the mission has to be accomplished. And we are working on air breathing propulsion. And I started explaining the cryogenic complexity when we were lighting the lamp. I think none of us could succeed the lighting the lamp less than 1 minute time frame. Everybody took 1 minute time, and of course, our elder took little more time. Doesn't matter. And in a cryogenic engine, hydrogen is admitted first, oxygen is admitted subsequently. And we switch on an igniter like this. If the igniter, if ignition doesn't happen within 600 milliseconds, it will end up with a explosion. And please understand, you know, even though we talk about eukaryotic, I don't think some of the boys are now also not entering into the kitchen and trying to do these attempts of switching on the gas stove. Now, can you tell when you switch on the gas stove, what is the probability of getting the flame in the first attempt? Any guesswork? Some of the female students, I think you do that, you know, or your mothers are only doing. You don't enter into the kitchen, I don't know. For me, whenever I switch on, the probability of getting that flame is only less than 50% time only. We are all very bad fellows. But whereas the female children, they are little more better, but even then the probability is 90%. But here in a cryogenic system or in a air breathing system, we have to get in the first attempt itself, otherwise it will lead to mission failure. And we have demonstrated a air breathing system where air is entering with a Mach number of 5 to 6. And first attempt we have demonstrated. You know, the successful people are the one who are not doing different things, who does things in a different way. And getting success in the first attempt is not equal to getting success in the second attempt. It is something different. And we are working on nuclear thermal rockets, and we are working on the high thrust engines. We are working on combined cycle engines, where the aircraft engine and cryogenic engine can be clubbed together to take people from one continent to another continent. And we are working on another important thing. When we talk about moon mission, Mars mission, if there is a life and people are to settle or something has to be done, you cannot carry propellant from, as Professor Sarangan nicely told. To go to Mars or moon, you can carry fuel. And to return journey also, if you have to carry fuel, then the rocket may not lift off from the launch pad. So we have to produce propellant in moon or other planets. And there is a small diagram is there, to get executed, that diagram, 20,000 crore is required. And right now I have put a team to study and break into components and go to industries, academia to work on the system. And we are occupying global leadership, a country which started very humble beginning. And we are building a G20 satellite for G20 countries for studying the climate, for monitoring the air pollution. We are building. And India is taking lead role. South Asia, we have built a satellite and we have donated and we have become a world leader. There is a satellite called NISAR, NASA ISRO synthetic aperture radar satellite. I don't know how many of you heard when Honorable Prime Minister recently he was in USA, a month back or so, and he was addressing along with the President USA, while he was addressing a fantastic statement he made. Both of our countries have built a satellite together. That is going to be launched from our country using our launcher. What a proud statement it is. I think it's a big event for us, and we are working in that area. And commercial launches. Today, 14 dedicated commercial launch services we have done. More than 5,000, 6,000 crore. I cannot comment exactly on the amount we have earned. And 433 foreign satellites we have launched from Indian soil. And we are going to have a launch of an American 6,500 kg communication satellite on commercial basis from Sriharikota in a couple of months. The rocket is getting built. And we have placed 72 satellites in precisely centimeter accuracy we have placed in the orbit. And today, India is really a commercially viable spacefaring nation. Space sector reform, lot of activities are happening. And ISRO supports lot of activities, including academia. Today we cannot claim that we are the only people who have done the job. Professor Sunil Sarangi, Professor Padi, and so many people from academia, they have contributed for space program. And we strongly believe in the teamwork. We don't believe leaving Professor Padi, I only should do. We don't believe in that. And we have to go together and we do the work together. And India's space vision is 2047 is given here. Now, dear friends, a country which started the space program with a humble beginning. 70 years back, we were there compared to advanced countries. Today, we have become #1 in a couple of places. And we have put great targets to become more number of places in the coming years in #1 position. And I am sure the type of Indian education system, the type of enthusiasm, the type of dedication, the type of innovative drive Indians are having, everything is possible. Nothing is impossible. And I want to say we are second to none in the world in not only utilizing the technology, also in making the technology. And innovative way, Indians are second to none. And when we celebrate 100 years of independence, Indian space program will be in par with any other country in terms of launcher, in terms of satellite, in terms of application, bringing the benefit to common man. With that, before I conclude my talk solely, let me thank Professor Acharya. He is such a person with a great stature. When I was a student, he became director subsequently. To enter into IIT Kharagpur, no student can just like that enter. That is a big domain. And he's a person occupying that position and making phone calls. When he made the phone call, I told my PA, you please tell his office not to trouble him, and I think we will talk to them. And such a person, because of him only, I am here, sir. I have to thank you and Professor Sarangi for this great opportunity for me to stand in front of these young children to talk. With that, before I take a couple of questions, I think by this time, some of you would have got little bored. So I want you to come back from that situation. So let me show the last and second video. Then after seeing the video, I will take a couple of questions. I think you can go and click the video. Video #1, you click. No, not that. Video. #1, you please click. Let us see the video now. Okay, you see the video, then we'll take a couple of questions.
Space ignites
Switch off the
a
lights.
boundless wonder that fuels humanity's relentless urge to explore. A cosmic symphony of planets, stars, and dazzling mysteries. It calls us to dive headfirst into the unknown, unraveling the universe's deepest secrets with unstoppable curiosity and an insatiable thirst for discovery. India commenced its journey into space research in the early 1960s, a time when satellite applications were still in the experimental phase globally. Dr. Vikram Sarabhai, a true visionary of India's space program, firmly believed that space technology could be harnessed to address societal and national challenges effectively. The Indian Space Research Organization, ISRO, was established in August 1969 and subsequently came under the Department of Space in September 1972. The prime objective of ISRO is the development of advanced space technology and application of space technology for societal, commercial, developmental, and strategic requirements of the country. 50 years ago, India built its first satellite, Aryabhatta, that was launched with the help of Russia, erstwhile Soviet Union, on April 19, 1975. Marking India's entry into the select club of spacefaring nations. SITE, an experimental satellite communication project jointly designed by ISRO and NASA, was launched in India during 1975 to make informational television programs to rural India, the largest social experiment to educate financially and economically backward community. Since then, 131 satellites have been conceived with state-of-the-art technologies, built and launched for communication, Earth observation, navigation, scientific applications, etc., for the benefits of humankind. Some of the major space-based services are telemedicine, teleeducation, disaster warning, weather forecasting, resource management, planning, etc., addressing the civilian requirements. From the nascent phase of transporting our first indigenous communications satellite, Apple, Ariane passenger payload experimental satellite, today we have established state-of-the-art facilities and proven our technical prowess in the field of launch vehicle capability. From the major challenge of having no access to cryogenic propulsion technology, affecting its ability to launch communication satellite, India overcome these challenges through successful demonstration of GSLV mission. Augmenting to this, India developed and qualified a new cryogenic engine with 3 times the thrust for its LVM-3 launcher in record time, setting 3 global benchmarks. These include completing development and flight with just 3 engines, achieving the maiden flight in 28 months, and conducting the stage hot test in only 34 days, faster than any other country. We aim for many such world records to be made in the coming years. India achieved its first successful launch to orbit with SLV-3 on 18 July 1980. The nation developed 6 generations of launch vehicles with advanced inertial and navigation systems, SLV-3, ASLV, PSLV, GSLV, LVM-3, and SSLV, and recently achieved the milestone of 100th launch in January of this year with the launch of GSLV F-15.
This mission is the 100th launch from our launch pads, which is very significant milestone of India. Our space program was conceived and started by visionary leader, Professor Vikram Sarabhai, and taken forward by generations of leaders
The fact that half of these launches were accomplished in the last 10 years alone indicates that our space sector has grown exponentially. India has demonstrated a unique approach for its space science satellites. The high success rate and the cost-effective nature of our lunar and Mars missions have caught global attention. India's first lunar mission discovered water molecules in the moon for the first mission. The second lunar mission, Chandrayaan-2, has the highest resolution camera, 32 centimeter, in the world that continues to map the moon. When Chandrayaan-3 satellite became the first satellite in the world to touch the South Pole region of the moon, it also touched the heart of every Indian, and the whole world watched and hailed the achievement. India became the first country to successfully insert a Mars orbiter on its maiden attempt in 2014, which also made a record as cost-effective mission. In 2023, it launched its first solar mission, Aditya L1, becoming the fourth country to do so, with the spacecraft now actively contributing solar data to the global scientific community. Indian space sector reforms aim to foster private sector participation and innovation in space activities led by InSpace with the support of ISRO and ENSEL through hand-holding and enabling the non-governmental entities, NGEs. This year, India will witness the first commercial launch vehicle, PSLV N1, realized by industry consortium carrying ISRO's technology demonstration satellite, TDS-01, demonstrating a host of new developments such as indigenous traveling wave tube amplifiers, etc. Today, we have a world-class ground infrastructure in the country, distributed across various states, including multiple launch pads, engine and stage testing facilities, and ground tracking facilities, including a 32-meter antenna for space exploration missions. ISRO is advancing quantum communication technology to ensure ultra-secure satellite-based data transmission in India. As part of our capacity building outreach activities, ISRO adopted multi-pronged approach such as establishment of Indian Institute of Space Science and Technology, IIST, Regional Center, delivering space-based courses, etc. As part of international cooperation and collaboration activities, one of the major missions being launched in coming months is ISRO-NASA satellite, NISAT. Another major endeavor is ISRO-JAXA mission to Moon, Chandrayaan-5, LoopX mission. The Indian space program has set its sights high in the next 25 years with the Gaganyaan program.
2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा जो हमें स्पेस के अज्ञात विस्तार को जानने में मदद करे.
We are looking forward to the first Indian Gaganyatri to International Space Station in the coming days. The first uncrewed mission for Gaganyaan is planned this year to demonstrate the associate technology for human spaceflight. ISRO has initiated the development of a super heavy lift rocket to take our Gaganyatris to the moon and back. The various initiatives in the space sector and the goals identified under the Space Vision 2047 will elevate the Indian capability in launch vehicles, satellites, and space applications on par with the leading spacefaring nations by the 2040-45 timeframe and contribute to the vision of Viksit Bharat by 2047. From church courtyards to cosmic frontiers, India's space journey shines as a triumph of grit, innovation, and vision. With space stations ahead and limitless dreams, ISRO proves space isn't just for exploration, it's for empowering a nation. The story has just begun, and the stars are only the start.
Thank you, sir, for the insightful talk. Yeah.
Yeah, please go ahead.
Yeah, so so I am an integrated MSc student and currently studying microbes. So when I talk about when I think about ISRO, it's more of rocket science and many things. But one more thing that came into my mind is all these things are happening just to check whether life exists outside and if it can exist outside. So till now, ISRO is I have a question are we able to mimic the environment of moon or Mars in ISRO such that we can check whether microbes can exist there or not?
No, we are in the process only. We are not done. That's why the sample return mission is meant for that type of purpose only. You have to take sample and say, even though other countries have taken everything, they will not share with us,
Yeah.
So we are going to take samples and we are going to bring back and try to understand a lot of things. And right now, a lot of understanding there. Probably you can go through our site, even Mars, the moon, there are hydroxyl molecules and lot of things are there. But then we have to have, say it is like this. The strength only respects strength. If you are not strong, nobody will share any data with you. If you are strong, voluntarily data will come through. And we will also share with them. So that's the place we stand. So we have to do a lot of fundamental R&D. That's the why we celebrate this type of technology innovation day, only to inculcate scientific temper among youngsters and try to do a lot of.
Thank you, sir. I think there is a future opportunity regarding microbes in ISRO.
Yeah, lot of opportunity.
Yeah.
In fact, sometime back, we were not having any connection with the doctors. But today, I am talking more on medical field because I was the certification agency chairman for the Gaganyaan program. So, to be frank, I don't know. When I used to get headache with engineering books, I used to read in the house medical books. But I never thought that that is really required at one point of time for me. Today, I have to understand much more about medical field because the health of Gaganyaan when a report comes, instead of some doctor come and explain better, you also should understand something, So thereby, today a lot of connectivity and we have signed some MOU with Sri Chitra Tirunal Institute of Medical Science. We are going to sign MOU with All India Institute of Medical Science. Today the space is really, Honorable Prime Minister used to say there should not be space between common man and actual space. And we are now connecting entire field, not only engineering.
Jai Jagannath. My dear scientist, would you like to tell me that how am I get to have a privilege to working under your guidelines in future? I'm a postgraduate student, first of all.
Lot of opportunities are there. Number one, probably if I understand, your question is how to get into ISRO system. Is it the question?
Yes, sir.
Yeah, I think directly put that question. Okay, there are a lot of opportunities. Number one, as a student, you can come for some internship. There is internship is available.
Yes,
and
sir.
so that you will understand little more better. And you can come for project teaching. You will understand. Then, of course, at the end of the day, in a population of 140 crore, the people who are working in the space sector directly is 20,000, and academic and everything put together maybe a lakh plus people are working. And then you have to compete and then get into the system. But another option is available. You can have your own startup. That is very easy route. Start something and we are there to carry, for example, if you develop a small camera, you make a biological experiment, and we are ready to accept and support you. And multiple ways you can enter into the system. One is like a government servant join. Another thing is you can work in this area through multiple ways. And I think we can have a direct dialogue. I will enable my colleagues to directly talk. Better you come for a internship or a project work, at least for a visit, so that you can spend some 2-3 hours. You will be enabled to some level, because when you are having interest, I don't want to put the interest down, and you will be enabled. So we will be happy to receive you in whatever capacity you want to come into.
Means a
But
lot.
permanent posting, they're all government, we are all government servants. So there is a government guideline, rules and regulations, through that only you can enter. Otherwise, other exposure is very easily possible. But once you keep a target, it is easy to enter into the system. You will work for that and you will enter into it. And all the very best.
Means a lot, sir. Means a lot.
Okay. Yeah. Yeah, fine.
Thank you, sir, for that visionary and inspiring address. Due to the lack of time, we will not be taking any questions now. We now request Professor Damodar Acharya, Chairman INAE Bhubaneswar, to kindly felicitate our chief guest as a token of our heartfelt appreciation and respect. It's now my pleasure to invite our director, Professor Hirendranath Ghosh, to do us the honor of presenting a memento to our distinguished chief guest as a mark of gratitude for joining us on this special occasion. To conclude this memorable evening, I will now invite Dr. Jayesh Goel to deliver the vote of thanks.
Hello, everyone. I would like to thank our esteemed speaker, Chairman ISRO, who took out time from his busy schedule and come here and give this wonderful and inspiring lecture. I'm sure all the school, college, and NISER students have enjoyed his lecture. So a big round of applause for taking. And finally, I would also like to thank all the volunteers who made this event successful, all the volunteers from the School of Earth and Planetary Sciences, the auditorium staff, and especially the NISER director who approved everything very quickly in 1 week's time. So thank you very much, everyone, and especially the audience for being patient and listening. And with this, we finally end this distinguished lecture. I request everyone just to stand for finally for our national anthem. Thank you very much, everyone. I would just request first school students to go out first because they're getting late for their buses. So requesting nicer students to allow them to go first, school students.
The school students, please proceed from the front gate.